everyone, welcome to our YouTube channel. Today we are going to discuss about linked list. Okay, in the previous video we had discussed what is array. Array is a static data structure. Okay, so array is used to store a contiguous values, or array is a contiguous allocation of memory. We had studied. An array is a data structure where elements are stored in consecutive memory location. In order to occupy the adjacency space, a block of memory that is required for the array should be allocated beforehand. That is the disadvantage of array. Okay, for solving that issue, we will use a linked list for it. Okay, so in contrast to this, the linked list is called a dynamic data structure. This linked list is called dynamic data structure, where the amount of memory required can be varied during its use. In the linked list, the adjacency between the elements is maintained by means of link or pointer. A linked list is a linear data structure in which elements called nodes are stored in a sequence where each node contains two parts. First part is data and second part is next. Okay, the data part contain the value or information to the node holder, and the next part, this next or link part, will hold a pointer to the next node in the sequence. Okay, the main use of that linked list is to allocate the memory. If we want, then we will have to allocate the memory. Okay, so a link or pointer, this link, or it is also called a nest, is a pointer, actually is an address memory locations of the subsequent element. Thus, in a linked list, data is the actual content, and link means to point the next node. Next data both are required to implement the functionalities of this data structure. Okay, an element in a linked list is specially termed as node. The element in the linked list is specially termed as node. This is one node, this is another node. So in this linked list we have four nodes. Okay, so each four nodes contains data and link to that next part. An element in the linked list is also called a node, and which can be viewed as shown in this figure. A node consists of two fields, data and link. Data is used to store the actual information, and link is used to store that address of the next node. Okay, so we have discussed about the linked list. A linked list is an ordered collection of finite homogeneous data elements called nodes, where the linear order is maintained by means of links and pointers. Links or pointers. Okay, depending on the requirement, the pointers are maintained, and accordingly, the linked list can be classified into three major groups: singly linked list, circular linked list, and doubly linked list. Okay, so we will go to singly linked list. Okay, how to read elements into that singly linked list, and how to traverse, and how to add the elements into the linked list at the front, middle, and end of the linked list. Okay, so what is the use of linked list? We will have to add memory location if you need. Okay, so unlike arrays, linked lists do not require a contiguous block of memory. Each node point to the next node, and the dash node point to none, indicating the end of the list. In this linked list, the last node, the link field contain a null value, which means that will not point a another node. No, that will not point a next node. Okay, here this is the first node. That node contain the data 10, and then link part of this node contain the address of next node. Okay, the next node contain the data 20, and that link field of the second node contain the address of the third node. Okay, that third node contain the data 30, and the link field of the third node contain the address of fourth node. Then fourth node contain the data 40, and then the link field of the fourth node contain the null value, which means the fourth node have not point to the fifth node. They are not pointing to any another nodes. Okay. So the linked list consists of the node with some sort of data and a pointer or link to the next node. Okay. A big benefit with using the linked list is that nodes are stored wherever there is a free space in memory. The nodes do not have to be stored contiguously right after each other like the elements stored in the array. So another nice things with the linked list is that when adding or removing nodes, the rest of the nodes in the list do not have to be shifted. Okay, so nodes in the linked list stores the nodes in a linked list stores link to other nodes, but array elements do not need to store links to the other elements. So that is the advantage. For that, instead of array, we are using linked list. Okay, so using linked list, we have to add that memory locations. Okay, we have to efficiently add that and remove the nodes. So next we are going to discuss about how to define a linked list. Okay, we know that linked list consists of nodes. Okay, we have discussed that linked list in linked list is specially termed as node. An element in the linked list is a specially termed nodes. Okay, so the element in the linked list. Then next we are going to study how to declare or how to create this node. Now we are discussing about single linked list. Okay, singly linked list or single linked list. Let's implement this linked list in C to see a concrete examples of how linked lists are stored in memory. In the code below, after including the libraries, we created a node struct which is like a class that represent. Here there is a structure that name is node. So the node is a structure. On that node contain a data and pointer to the next node. This node structure contain data and that link to that next node. The link or we here we had mentioned that link as nest pointer to the next node. Okay, so it is a self-referential structure that data will also point to that structure of same data type. Okay, here structure node star nest. Here the node star is a pointer to a node. This node star is a pointer to a node. The node star will hold the address of node in the linked list. Specifically, it is a pointer to a structure of type node. This is commonly used in linked list implementation to refer to node in the linked list. That node star. Okay. We move on to that code. This is the single linked list. Okay, here in this linked list there is one head and the linked list contains four nodes: first node, second node, third node, fourth node. The first node contains the data 1, second node contains the data 2, third node contains data 3, fourth node containing data 4. Okay, so what we had studied in this line of code, we had discussed, we had created a node struct node which is like a class that represents or that is used to that structure is used to store the data at the address or link part to the next node. Okay, the node containing data and pointer to the next node. Next we are going to discuss about the representation of linked list in C. In C, the linked list are represented as a pointer to the first node in the list. That reason, the first node is generally called head of the linked list. Okay, each node of the linked list is represented by a structure that containing data field and a pointer of the same type as itself. Such structure is also called a self-referential structure. So that is the uh, code for that. Then this structure is also called a self-referential structure, which means that structure will also reference to the same structure. Okay, what is self-referential structure? The structure that contain a data field and pointer to same type as itself. Okay, so such structure is called self-referential structure. You have studied the structure in C classes. Okay, so next we are going to discuss about the type of linked list in C. So there are three main type of linked list in C: double linked list and circular linked. In this next lectures, in the next lectures, we will study about how to insert the nodes in front and middle of single linked list, double linked list, and circular linked list, and how to traverse through that linked list, and how to delete the nodes from front end and middle of the linked list. Okay. So the linked list are three types: single linked list, double linked list, and circular linked list. Okay. So linked list can be classified on the basis of type of structure they form as a word and that direction of access. Based on the classification, there are five type of linked list. Sorry, five based on three types of linked list. Three types of linked list. What are they? Single linked list, double linked list, and circular linked list. Okay. So next we are going to discuss about the single linked list and the operations on single linked list. Okay. In this program, in this lecture, we will discuss about how to insert the node into the linked list and how to save the data to that node and how to print that single linked list. Okay. So single linked list means a linked list or a single linked list is a linear data structure that is made up of group of node in which each node has two parts: data and the pointer to the next node. Here the next is the pointer that will point to that next node. That means this next node contain have one address. That address will save into the next part of this first node. Okay. The last nodes also known as tail. The last node is also known as tail. Point is a pointer. This point to none, indicating that the end of the linked list. Okay. I will show one figure. This is the one linked list. This is one linked list. This is one node. This is another node. In this example, we have four nodes. Okay. So first node contain the data 3. Second node contain the data 5. Third node contain the data 13. Fourth node contain the data 2. Okay. So the head node will point to that first node. The head node contain the address of the first node. The first node address is 0x7f28 is the first node address. Okay, the head pointer will save that address. Okay, here I will show the head. There is one pointer. That pointer will save the first node address. Okay, that head is the pointer that will store the first node address. We had mentioned here in C, linked list are represented as a pointer to first node in the list, and for that reason, first node is generally called head of the linked list. Okay, that head will store the value of the first node address. Here the first node contain the value 3, and then second node contain the value 5 that we have discussed it. The last node contain the value 2. Okay, then the second node address is 0x7f42, and third node address is 0x7f3d. Fourth node address is 0x7f35. Okay, the first node, we know that the node containing the data part and link part. The link part of the first node had saved that second node address. What is the second node address? 0x7f42. That will save into that first node link part, 0x7f42. Okay. So moving on to that next node, second node. In the second node, data part containing the data 5 and the address part containing the data 0x7f3d. What is 0x7f3d? The 0x7f3d is the address of the third node. 0x7f3d is the address of third node. Okay, and then we move on to that third node. What is the value of the link field in the link part in that third node? The link part contains the address 0x7f35. That will point to that fourth node. What is 0x7f35? It is the address of the fourth node, 0x7f35. Okay, the third node containing the data 13 and the address 0x7f35. Moving on to that fourth node, the data of that fourth node is 2, and that in the link field of the fourth node contain the null value, which means that will not point to any other nodes. Okay, so this is the pictorial representation of single linked list. You have to draw this figure in the exam. If you put the same four nodes from the previous example together using the new visualization, it looks like this. As you can see, the first node in the linked list is called head and the last node is called tail. The first node in the linked list is also called head. Okay, the head will point to that first node. The value of the head is the address of first node. Unlike with array, the node in the linked list are not placed right after each other in memory. This means that when inserting or removing a node, shifting of other nodes is not necessary. So that is a good thing. So we have to easily manipulate that data. We have to easily add the nodes into that linked list. We have to easily delete the node into that linked list. We have to easily change the values. Okay, we have to add extra memory to that linked list. It's easy. So instead of array, we will use linked list for the proper management of data structure. Let us implement this linked list in C to see a concrete example of how linked list is stored. Okay, so next we are moving to one example. I will show one example how to create a linked list and how to add elements into that linked list and how to traverse through the linked list and how to print the linked list. Okay, so this is the program. Okay, we will try this program in one online compiler. I will show the output. So we are going to discuss the code. In this code, they had shown uh, how to create the linked list and how to add the data. Here, this is the linked list. The first node contains the data 3, and the second node contains the data 5, third node contains the data 13, and fourth node contains the data 2. Okay, and the last node, the link part contains the address null. Okay, so this is the code here. Next, we are going to discuss the line by line explanation of this code. Here we had used the two header files stdio.h and stdlib.h. Next, we are moving to that node structure, typed up struct node into data, struct node star nest, and node is a structure variable. Here we had used the node as a structure variable. Okay, you had studied about structures in C programs. When we define a linked list node, we typically create a structure that contains the data and a pointer to the next node. Okay, here the data is declared as data and the pointer to the next node is declared as next. Okay, this line of code, we have two data. One is storing the values and another is storing the link address of the next node. When you create a linked list, when we create a linked list node, you usually work with the pointers to dynamically allocate memory for few nodes. That's why we are using this nest. The node star type is used to reference nodes within the linked list and to link them together. Okay, so why we use that node star? The node star type is used to reference the node within the list and to that link them together. The main use of the node star is to manage linked list operations such as inserting, deleting, or traversing nodes. Here we had declared the structure. The create node function, we have one create node function. Okay, create node in data, node star new node equal to node star envelope size of node. If node new node, then print memory allocation failed, exit one. Then, or if the new node have some value, then new node data equal to data, new node next equal to null, return new node. Okay, this is the code for creating a new node. Okay, next we are moving to uh, that function. The function name is print list. It is used to print the node data. Okay, print void print list node star node. Node star is a pointer to node. Okay, and then while node, which means node have some values. Then print percentage d node data. Then node, after printing the value, this value, the node will change to node equal to node next. Okay, then print in null at the end of the section. In the main part, we had created four nodes: node 1, node 2, node 3, node 4. Node star, how to create the node star node 1 equal to create node. Okay, the data is 3. Okay, then we had called the function create node. After calling, the function will goes to that this function definition, and then in this function definition, using malloc is a dynamic memory allocation, we will create the node. Okay, we will create the node of the structure type node star. Okay, node star, we had studied that node star is a pointer. Node star is a pointer which assigned to that variable new node. Okay, so what is node star? We had studied node star is a pointer that points to that node. The envelope size of node function allocate enough memory to hold the node structure. The size of nodes returns the size of node structure, which includes the data, an integer, and the next pointer, the pointer to the node. The result of malloc is uh, cast to that node star pointer, which is assigned to the variable new node. This is the new node. Okay. If the malloc fails to allocate a memory, return null. This is an error message is printed. Okay, with with a status of 1, indicating failure. After that, if the memory is allocated successfully during the dynamic memory allocation, then the function will set the data. New node data equal to data, new node data equal to data, and new node nest equal to null. New node nest means new node link is equal to null. The data is passed to create node function is assigned to the data field of the new node. That data will pass to this data field of the new node. Okay, and then we had initialized that new node nest equal to null. Since this is a new node, its next pointer is set to null, indicating that it does not point to any other node yet. Okay, and return new node. Finally, the pointer to newly created node is returned to the caller so that it can be linked to the nodes in the list. Who is the caller? The caller is node 1. Okay, node star node 1. The value, the address of the first node will save into the node 1. Okay, node 1 is a pointer. So from this line of code, return new node, the value of new node will save into that node 1. Okay. In the main function, we had created four node 1, node 2, node 3, node 4 using the create node function. After that, node 1 nest equal to node 2. Okay, node 2 nest equal to node 3, and node 3 nest is equal to node 4. Okay, then using the print list of node 1, we will print the data of that linked list. Okay, at the end of the section, using free function, we will remove the memories. Okay, we will remove the allocated memories. So using free function you have to deallocate the memory. Free node 1, free node 2, free node 3, free node 4. Okay, so when we click on the run button, it will shows the datas of the linked list. What is the datas? 3, 5, 13, 3, 5, 13, 2. At the end of the section we will print that null value. Okay, so inside the main function, four nodes are created, linked together, printed, and then memory is free at the end of the section using free function. Okay, so it is a good practice to free memory after we are done using. Okay, so it will free the memory using free function. We will free the memory, so it will help us to uh, avoid the memory leak. So memory leak is when memory is not freed after use, gradually taking up more and more memory. We have studied that this create node function is in C is used to dynamically allocate memory for new node in a linked list. Set is a linked list. Okay, so this create node function will set the data. Okay, data of the node and initialize the next pointer to null value. This function is essential for building the linked list where each node holds data and points to that next node. Okay, here using that create node function, we are added the nodes. Okay, whenever you want to add a new node, either at the beginning or middle or at the end of the linked list, for example, to create a node at the with the data 5, or to create a node with the data 8. Okay, so how we will create that node star node 5 equal to create node of I I need to insert the data 8 into that linked list. Okay, so I will put 8 here and press semicolon. Okay, then we are added the 5 nodes. When I click on that run button, we will see that the data 8 has not printed. Why? Here we had node linked that data node 5. Okay, so after this line of code, you will enter one line node 4 nest equal to node 5. Okay, then click on the run button. I am waiting for the output. Okay, so on that fifth node we got that data 8. Okay, so here we had created that 4 nodes, 5 nodes. Okay, so what is the main use of node star? This node star, so you have to please listen. The main use of the node star is to manage the linked list operations such as inserting, deleting, or traversing the node. Okay, the node 1 nest is equal to node 2 means that this node 1 nest is equal to node 2 means that the next pointer of node 1 points to the node 2. The next pointer of node 1 means the link part of the node 1 will point to node 2. We know that node contain two parts, data and link of the next node. That link of the node 1 will point to node 2. Okay, this arrow operator. this arrow operator. This is also called as arrow operator. Okay, this operator is used to access the member of a structure through pointer. For example, node, arrow, data, or nest. Access the, in this case, node, new node, arrow mark data equal to data. Access the data of the node. Okay, and node, arrow, nest. Access the pointer to the next node in the list. Okay. Okay, so this is the code part. I will share the link of this Word document in the descriptions. Okay, so you have to study, you have to write the notes on your book, and you have to do it in your online compiler or offline compilers. Okay, so I hope you got that idea. So let me know if you need further clarification. You have to comment your doubts in the comment section. Okay, I will put my numbers in that description or the title section. Okay, so if you have any doubt, please put your message in the comment section. Thank you. Thanks for watching. If you are not subscribed our channel, please subscribe and click on the bell button to get the more notifications. Thank you.